1155D, beautiful array, educational code forces round 63, Div2 D. Right, so we've been given a array of n integers. Uh, the elements could be positive, negative, both, and we need to find the sub array of maximum sum. We have to find the maximum sum sub array after performing an operation, and the operation is we've been given an integer x. We can choose any subarray from the array and multiply each of the element by x, and after this operation has been done on the array, we need to find the uh, maximum possible subarray sum. So the way we do this is, first of all, my first thought for solving this question was, uh, let's say we were not allowed to do the operation of multiplying by x, then this would have been a standard DP problem. Uh, yeah, this would have been a standard DP problem. Now we have multiplication by x. So take the case when x is greater than 0. Then and maintain two arrays dp max and l max, where dp max is the maximum possible subarray of sum of subarray ending exactly at I, and l max is the uh, start index of the subarray corresponding start index of the particular subarray uh, for which the out of so L max is basically the start of that subarray for which out of the class of subarrays ending at I, uh, and having the maximum sum. Okay, so with these two definitions out of the way, we this is a simple transition for calculating this dp, both the dps, and similarly we maintain dp min and l min. Now if x is greater than 0, answer would be nothing but x times dp max of I, maximum over all the indices. The reason being, uh, so it's basically uh, it's something like uh, taking the so before multiplication we have a particular subarray with the maximum sum, and we multiply those elements by x. That will give us the maximum possible sum after the operation. Okay, and similarly for x less than 0, this might not be the case, because first of all we for x less than 0, first of all we calculate dp mins and identify the subarray uh, for which the dp min of I is the minimum. So, and let's say it is the subarray ending at I and having L min equal to L. So this is the subarray under consideration, and all these subarray elements would be multiplied by X. Now, after this operation has been done, we calculate the maximum possible sum subarray on this modified array, because it might so happen that uh, that okay, do we need to do this though? Would this suffice or not? Let's think about it. I mean, what I mean to say is, would x into dp min of I suffice for x less than 0 or not? Okay. Uh, Well, I'm not really sure, but this is anyway a safer option. This option, because even this part could have been done in this way. That is, first multiplying all the elements by x and then calculate the max sum subarray on this whole subarray. But the problem is what to do when x is equal to 0. That is a problem that I couldn't figure out, and hence I had to try a different approach. And the different approach is formulate the DP in this way. That is define DP of IS as maximum possible subarray sum ending at I, with the ith index being in state S, and we define of state that the DP is in as follows. So we're allowed to like multiply all the elements of a subarray by x, right? So we can essentially partition the array into three parts. The part before the chosen subarray, this is the chosen subarray, the chosen subarray, and the part after the chosen subarray. This is state 0, this is state 1, this is state 2. So the answer would be maximum of dp of I0, dp of I1, dp of I2, because naturally we need to for every state we need to find the maximum possible subarray sum ending at that particular index when uh, the ith index is in state 0, it is in state 1, and when it is in state 2, take the maximum out of these. And the transitions are given by like dp of I0 is equal to maximum of AI comma AI plus maximum of dp of um, okay, this is AI plus dp of I minus 1 0. dp of I comma 1 is maximum of AIX plus dp of I minus 1 0, AIX plus dp of I minus 1 1, and like max of this also. And dp of I comma 2 is nothing but maximum of AI comma AI plus max of dp of I minus 1 1 comma dp of I minus 1 2. Yeah, this is the transition. Looking at the code is very simple, just this long and exactly what I just described.